Okay, so here we are, first lesson for real of this video series, and this one is just really basic about measurement and what you use for measuring. So looking here at these basic implements, these are the things that we'll be using often, one of these in class during our laboratory procedures. So I just wanted to show you really quick. I'm sure you're familiar with all of these, but this is just a formality. So here we go. We're going to zoom in here. This is what we call a measuring cylinder. We use that for measuring liquids. It's also called a graduated cylinder, and it has various markings that tell you how much liquid is in there if you read them properly. This is a tape measure right here, and then over here we've got a ruler. So you're obviously familiar with these. A ruler is called, in British system sometimes, they call it a rule without the R at the end, so just in case you ever see that. Other things that you're looking at here would include a stopwatch, obviously, start, stop, and reset. We'll use those. And then this right here is a LabQuest data logger. We won't be using this kind all that often, but there is a similar one that we hook up to the computer. It is also a data logger, so get to know those a little bit. So here we have some sample questions of actual questions that have been on old IGCSE tests. You can see here a graduated cylinder, and they have a liquid in there, and then they have a liquid plus a stone. And what are you supposed to figure out? The volume of the stone. So all you do is you subtract the different readings there. You subtract this reading from that reading, which you can do by figuring out how much each little increment is. And if you do, you can see it's 50 here and it's 100 there. There's 5 marks, so that means each mark must be 10, meaning this one here is 75. And then if we look at this one here, we have 100, 110, 120, 125. So 125 minus 75. So the correct answer should be that one. Alright, and moving along, here we have a stopwatch. Again, we've got a situation where you have to subtract the 2 readings, because what it tells you is that this reading was from a previous athlete, and then this reading is after this current athlete finishes. So what you have to do to find out the time for the current athlete is you take this time and you subtract that time. Again, you need to kind of zoom in there, figure out how many each increment is, and you can tell there is 5 seconds, 5 marks. Each of these is 1 second. However, the little marks in between, there's only 5 of them, so each of those is 0.2. So you've got 10, 11, 12.4, because it's 2 dots, 2 little hatch marks. And then if we move over to this one, we have 20, 21, 22, 23, and 4 hatch marks, so that's 23.8. So what we have there is 23.8, and we subtract 12.4, and we do that math. We're going to come out with 11.4 as the correct answer for this problem. So the point of this is just to let you see a couple of actual problems that you might have to solve in this sort of a measuring sort of a thing. They're pretty easy, as you can tell. Now here we have a different way of measuring things, which I want to talk about briefly. Here is a picture of a pendulum, which you've probably seen a pendulum swing. It's, inside a grandfather clock, or just anytime you have something hanging from a string and it's swinging back and forth, that's a pendulum. And then this is a stack of paper, which of course all of you are familiar with. So as a pendulum swings, it goes through its period really rapidly. The period is how long it takes for one complete swing from here all the way over and all the way back. So in order for that to occur, it happens pretty fast, actually. So what you have here is you want to be able to measure how long that takes. If you take your stopwatch and try to start it just as you let go and then let it swing and come back and stop it, it's probably a second or less. And as you know, there's error in how long it takes you to push the buttons. So if you just measure one single swing, you're going to have problems there because you're going to have all of the human error involved. So how can you do a better job of figuring out what the actual time is for that? And it's pretty simple. You let it swing back and forth, say 10 times. So 10 swings, and then you divide by 10. And you can find out the time it takes for one swing. And that will tell you the period of a pendulum much more precisely than if you just try to time one single swing. Same thing with the thickness of a piece of paper. If you try to hold a piece of paper up to a ruler, you're not going to be able to measure that, right? It's just too small. Now, however, you could take a stack of, say, 100 sheets of paper, and then if you have 100 sheets, you can measure that with a ruler, divide by, say, 100, and you will get the size of the thickness of one sheet of paper. Alright, so now I'd like to talk a little bit about some special measuring tools. These are designed for measuring very short distances, very small thicknesses. So this is a second way that you could measure, for example, the thickness of a piece of paper. This first one over here is called vernier calipers. So let me zoom in on that. Vernier calipers. It looks like this. This part here is movable, and if you're measuring outside of something, which is usually the case, the thing is going to go in between these jaws right here. Now, if you wanted to measure the inside diameter of, say, like a cup or a graduated cylinder or something like that, you could use these teeth up here. But we'll almost never be using these in class. If we ever use these tools in class, we'll be using this part to measure the outside diameter of things. Now, what's interesting about the vernier calipers is that they can let you measure right down to very small tenths of a centimeter, and even smaller than that, I believe. So here's how it works. We're going to zoom over to this one here so you can see a little bit better what's going on. All right. So in this picture, we're measuring a nut, a hex nut. All right. So the hex nut is clamped between the jaws there of the vernier calipers, and the reading on the scale is up here above. So this is in centimeters. All right. And you may be thinking to yourself, what on earth, how do I read this? Well, here's how. All right. So here we've got your markings for the centimeters, 1, 2, 3, and so on. And then you've got tenths of centimeters in between, 1, 2, 3. So each of these lines here is a tenth. So this line that says 0 lines up next to one of these lines for tenths. So basically you can straight away read this as 2 point and then 1, 2, 3, 4. We're almost to the 5, but not quite there. So we're 2.4 something centimeters. All right. Now here's the tricky part. To find out 2.4 what centimeters, you have to move over here. Now as you're going along this line here, you'll see that each of these markings on this second scale here, this is called the vernier scale, each of those markings is offset from the ones above it here. So that does not make a straight line. You can see here, that's offset, it's jagged. Those don't line up with each other. Same here, all the way down the line, none of these markings line up until you get to that one right there. This marking lines up very nicely, exactly with the markings above it. As we continue on, this one here is pretty close, so you might say that one is it. This one you can see already is starting to be offset, and this one, and then here, this is clearly offset from the line above it. See how it's jagged there? It's not a straight line. So you're looking for, of all of these numbers here, which of them lines up exactly with the hatch mark above it. So here, jagged, 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 jagged line there. These lines in here all look pretty close to the same, so it would be a little bit of a toss-up. But according to this drawing, this is the one that lines up exactly with the hatch mark above it. So that would be 2.47. So 2.4 right here plus 0.07 there gives 2.47 centimeters. And now we're going to look at a similar device called a micrometer screw gauge. This is what it looks like here. It's got teeth. You put the thing you're measuring in between those teeth. This is the barrel that you twist, and this is called a clutch, which prevents you from damaging the device. Alright, as we look in closer, here's a close-up of the scale where you can read it. And then we're going to zoom in on that so I can tell you a little bit about how you read this device. So here we have the hatch marks that tell you centimeters. Here we have hatch marks that tell you half centimeters. This barrel is marked with 50 hatch marks. Each of those hatch marks is 1/100th of a centimeter. So basically what you're looking at here is you're going to twist this barrel around until it's tight against whatever object it is you're measuring. So then you're going to, when it's tight, you're going to look at this measurement. So what we have here is 0, then a half, then 1, then 1.5, 2, 2.5, and so on, up to 5, and then 5.5. So the marking that we can see here is 5.5, the half mark. So we're already at 5.5 centimeters on this scale. So let's write that down. We're going to say 5.5. Alright, now what are we going to add to that? We're going to add to that what we see here on the scale. So looking at this, we want to see which of these hatch marks here lines up with this center line, and it's this one. So what is that one exactly? That one is going to be 25, 26, 27, 28. So that one is going to be 28 hundredths. So 0.28. So we've got 5.5 plus 0.28. That's going to equal, let's see, 5.5 plus 2.8 equals 0.28 rather. It's going to be 5.78 is what we would say is the reading on that device. Alright, you can go back and watch that again if you want. This video is already getting too long, so let's wrap it up. Alright, and the last thing we want to talk about is a common mistake that can be made when you're making measurements and taking readings, and this is called parallax error. Parallax. So really quick, I'll just do this as fast as possible because this video is very long. So parallax is what happens when you don't look at your scale straight ahead. So basically, the bottom line is you need to be doing this. You don't want to be doing this. You don't want to be doing this. And this illustrates how you get the wrong reading if you're not looking straight on. If you look at an angle, if you're looking from below, for example, you're going to read it as this reading as 19.82 possibly. If you're reading straight on, you can see that it's 19.7. That's the correct reading. If you're looking down and not even, you're going to get 19.62. So basically, your eye is going to see the wrong thing if you're looking the wrong way. All right, so you need to be looking straight on. That's the bottom line of avoiding parallax error. All right, so one other quick example. Let's say you're looking at this thing right here, which is something we're going to be doing actually, very similar to this later in the class during one of our labs. So here, again, you need to be looking straight at this arrow on this hanging thing here. This is a spring with a load on the end, and the spring is stretched. So the person is trying to figure out how far has it stretched. They're using this ruler over here to figure that out. Now, if they don't look straight at that arrow, they're going to end up either measuring too far down or too far up on the scale. They're going to be off by, in this case, either 0.2 too high or 0.2 too low. So anyway, you're going to measure either too high or too low if you're not looking straight on. This is what you want to do, not this, straight on. All right, great. So that's our video about measuring. Again, a lot of this is pretty obvious. Some of it should have been new information to you. I hope that this was helpful. Again, you can always watch it another time if you need to, and see you in class. Thanks.